Today we're going to be working on another Amazon's interview question. This is Leetcode question number 51 and coins. So you're going to be given that for a square chessboard, you have been given how many rows and columns, which is going to be equal to, both of them are going to be equal to n because it's a square. It's a square checkbox. Sorry, square chess box. Square chessboard. So we have n is equal to 3. So basically the thing which we're going to be returning is, first of all, depending on how many solutions we come up with, that's going to be the number of string arrays. So in this case we are returning two string arrays. In one array we have a complete solution that we are telling that do not put any coin on the first place, do put the first coin on the second place, and do not put the coin on the other two places. So the dot means we're not putting the coin, and the Q means we're going to be putting the coin. So in this one, I think is the depiction of this first board on the left hand side, and this is the depiction of the second board on the left of the, on the right hand side. These are the only two solutions which exist, and that's what we're going to be returning, the position of all the coins in all the solutions. The algorithm is going to be that we're going to be going through the matrix, right? And initially we're going to go through everything, and we want to create the matrix which is going to be the exactly the size of a character of n into n. So if we have been given an n as an input, if the n is our input, we're going to be creating a matrix of n cross n and initialize it by putting a dot everywhere, like, and this is like a character array, character 2D array, and we're going to be filling it up with a period or a dot. That means that in terms of how much space we're going to be taking, if we ignore the call stack space, because we're going to be using a helper function which is going to call itself again and again, if we ignore that, we're going to be using n cross n space in order to solve the problem. So in the end, once we have that matrix ready, we're gonna say that sender is, which is basically a new array list, and it's empty, and one thing we want to be sending is 0, which is the index. And once you send it to a helper function, we should have the result ready, and that's what we're going to be returning. What our helper function does is like what it does is like it sees that there are a couple of things. What is the size of the matrix dot length, right? Sorry, what is our index? When the index becomes equal to the matrix dot length, that means you have, so far you have filled it up correctly, and it is the time where you're going to be taking your matrix, whatever is the current state of the matrix, and send it to a convert function, because remember, the matrix is a character array, a character 2D array. We want it to be converted to this representation. So basically what the convert, and we're going to be talking about it, does is like take that 2D array representation of the matrix and convert it to a an array of string. That's all what the convert function does. Once you have that ready, you're going to be putting it in the result, and then we're going to be returning it. And just so that you know that why we are not, when before converting it, because it was an array list, why we are not saying new list and then doing it, because we are going to be given a new string every single time by this function. That's why we do not need to say new list or something like that. Okay, so that is the condition when the index has reached equal to the length of the like basically because both of them, the rows and columns are equal, so you can say that the total number of rows in the matrix, when it has reached that, that means everything is good so far, we are ready to put into it. Now when we start with 0th index, right? So what we're going to be doing is every single time we're going to start with I is equal to 0 to the length of the matrix. Like we're going to be going through uh, all the, so this gives you the total number of columns. So we're going to be going through all the columns, right? And we're going to check before actually putting at that particular location, like the matrix of I, which is the column. So sorry, we are going through different columns, but this is going to take the position of the row. So the first one is the row, so at 0th row and that particular index, right? So that index, and then, right, so this is gonna, sorry, so let's say that, yes, again, let's say that the I is equal to the row. Okay, I is equal to the row, it starts from the 0 and go to the all the rows. So this is gonna make it to the row, and the index is basically we're covering all the columns in the index. So before putting q in there, we're gonna say that tell me if I put a q there, right, is it gonna be a valid one or not valid one, right? And if it says it is valid, then we're gonna be basically putting it once, sending like after putting it, calling the helper function again with an incremented index, and then after that again at the same point putting a period, because just like we do in permutation or combination or any iterative solutions where we are putting something and removing it, so instead of just removing it, we are replacing that q with a period. So we have a matrix, we have a result, and we have an index plus 1. Now that would be it. And like we can actually, because the everything is done by the valid, if it is a valid location, you can actually check it, go to the next one, check it, go to try to put it in. If it is successful, uh, and then you can put it in. If it is not successful, it says no, you cannot put at that particular location, because we are going through everything. The basically the index is making us go through the columns, and we are going through the rows every single time. So basically there would be an instance where we are going to be hitting every single box in that n cross n matrix. So yeah, so now we're going to be covering two things. Convert, basically if you have been given that matrix, a 2D character array, character matrix, all you do is like create a new array list, go through the number of rows of that input dot length, and then create a temporary a character array, and then change it to a string, and then put it into that result. And once you are done doing it for all the rows, you can return the result. So that would take that 2D character array and actually convert it to this array of strings. Now is valid, the way we're going to be checking is valid is like, so it's going to be like we're going to go through the row, and we want to see that there is no other than that particular index where you want to check, there is no other coin in that row. Similarly, we're going to do vertically for the that particular column. For that particular instance, there is no other no other coin in that column. Then for the diagonal, we're going to do four directions. Let's say if I'm checking this orange box, I'm going to go top right this direction. I'm gonna go bottom left this direction. I'm gonna go bottom right this direction, and I'm gonna go top left this direction. So for a diagonal one, I'm gonna be having four loops going here, 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 and here. Okay, let's cover this one. In order to check the validity of that, you're gonna tell that n is the matrix length, or you could have just sent the n along the in the arguments. You are checking horizontally by saying that cover all the columns and make sure that you do not see any other queue other than where you are checking, because you have been given I and J where we are putting the queen. Okay, for every single row, do the same thing. Check that there is no other queue uh, other than where we are trying, other than the row we are trying to put in. And that would be like if any of these is like, if you see a coin, just return false. Now, as I said, for the diagonal one, you have an I copy which is I negative 1 and J copy which is J negative 1. That would bring you on the top left hand side. So if you're checking here, that's gonna bring you here. So starting from there, I copy as long as I becomes like greater than equal to 0. Both of them, we start from here and we keep going as long as I and the J copy is greater than 0. Keep looking for this direction that you don't see any Q. If you see it, return false. And while you want to keep going to the top left, you want to keep decrementing I copy and J copy. Okay, again, we're gonna give new values to I copy and J copy over here. I plus 1, J plus 1. This time we're gonna be covering bottom right direction. And again, keep incrementing both of them, keep looking for that, and that would cover this bottom right direction. Now give another value I plus 1, J negative 1. So I plus 1 would be this, J negative 1. So if it is this green, I plus 1 would be this, J negative 1 would be this. So this direction, top right. So keep incrementing the I, keep decrementing J would cover all the ones in the top right diagonal position. Then the last one is I negative 1 would be this, J plus 1 is gonna be this. This is gonna cover the all the bottom left. And in that case, keep decrementing, keep incrementing. Very naive way. I'm sure there could be better ways of like magically doing that, but I mean, this is not gonna, in terms of the complexity, time complexity, it's gonna stay the same, because all you are doing is like looking for that particular row, column, and the diagonals. Okay, that would give us our result. In terms of the time complexity, basically we are going through every single row and column, so that's gonna make it O of n square. And then you are validating every single time that whether or not there is another coin in there. So in that case, when you are validating that, the worst case could be that maybe you have gone through, although you are just going to be going through that particular row, column, and the diagonals. But let's just the upper threshold, keep the upper uh, like upper bound, that okay, maybe if I just want to simplify my complexity, I may have been going another time through all the chessboard. So that would be another O of n square. So basically, it's gonna be an O of n raised power 4 would be the time complexity, which would bring us this result. That's all I wanted to cover in this video. Thanks for watching.